Hi everyone, this is Victor and with Harshit. We are presenting our project about heart disease risk prediction. And we are focusing specifically on using interpretable machine learning to examine whether a patient is under high risk of heart diseases. So the data was originally released on Kaggle competition, and is based on well-established heart disease benchmarks. Use the medical machine learning literature, and you can see the dimension of the data set. It has 4,220 patient records, and we have 21 features, with one of it is our target variable heart diseases, and other 20 is numeric and categorical variables. And before modeling, we perform several data cleaning and processing steps to ensure our data has usable and realistic data. So some key steps we did is to impute each missing values with maybe not willing to tell or unknown, and also standardize inconsistent categorical labels like female and F, male and M. And also we do a one-hot encoded for categorical variables to create dummies. This is for our logistic regression. And we also do some manual ordinal encoding for random forest models. So on the right, we can see our EDA shows that there are some clear patterns between the predicting variables and targets. So for example, the age is highly correlated with heart diseases, and also different work type shows different frequency of getting heart diseases. And we built three kind of models. So first is the naive classifier, which is only a reference point. So it's just like random guessing, only assign the majority of the class to the test data set. And the next is using logistic regression. It was trained using both numerical feature and one-hot encoded categorical variables. And then we try to use random forests, different random forest variants. So there is models with the one-hot encoding categorical variables. We have manual ordinal encoding models, and also we try to like fine-tuning the hyperparameters. And as expected, so the naive baseline model is the worst. It's just like random guessing. But surprisingly, the logistic regression actually performed quite well. The random forest model doesn't outcompete the simple logistic regression. So the logistic regression will be our final model. It's simple and easy to interpret. And from both models, we extract some key risk factors. So on the left, we can see the key risk factor from logistic regression. They are exercise-induced angina, old peak, male sex, smoking relating features, and also age. And as well as we also have, this is proven by the random forest model, old peak and age, they are the most important one. So overall, this project shows that interpretable models like logistic regression can achieve strong predictive performance. And we also build interactive demos. So Harshit will show it to you.
We can look at the decision threshold at the top, which shows the ROC trade-off. Adjusting this ROC trade-off lets us split the difference between a positive and a negative diagnosis. There's a disclaimer in the bottom here for educational use only, so don't rely on this data, and this is only for educational purposes for the purpose of this project. Here we have pre-filled some information about a certain patient with certain characteristics. These are only few of the characteristics that are used here from the dataset. There are many more others, but we have used a baseline value there to not overwhelm the user here for testing our model. And if we click on the predict risk button, we will be able to see a person with this characteristic, what's the probability of them having a heart disease. And if we scroll to the bottom, based on the ROC value, we see this person, for example, has a high risk of having heart disease. And the interpretation is also mentioned at the bottom. So thank you very much.